In this video, we're going to talk about how to use the ideal gas law in relationship to molarity, molar mass, and density. We're going to start out with molarity. So, the ideal gas law is PV equals nRT. Pressure times volume equals moles times the gas constant times temperature. The molarity equation is molarity equals moles divided by liters. Those are the units, so if we put it in as variables, this would be our moles divided by our volume. So I want you to notice that in both of these equations, we have volume and we have moles. So we need to rearrange our gas law equation in order to have something that looks like the molarity equation, moles divided by volume. So if we take our gas law equation, PV equals nRT, and we divide both sides by RT, we now have PV over RT equals N. Okay, so now if we divide both sides by V, that's 1 over V. Our volumes cancel out on that side. And now we have P over RT equals N over V. That N over V is the same thing as molarity. So we can write this as molarity equals P pressure over RT. So this is how we relate. This is how we can include molarity in our ideal gas law equation. So let's try some practice. Pause the video and take a minute to try these practice questions on your own. So for number 1, we are given, the question is, what is the molarity? That's what we want to find. If we have a volume of 94 milliliters at standard temperature and pressure. Well, we know that molarity equals P over RT, okay? So if we have standard temperature and pressure, that means we're at 0 degrees Celsius and 1 ATM. 0 degrees Celsius is the same thing as 273 Kelvin. So our molarity is going to equal our pressure, that's 1 ATM, divided by our R, which is always 0.0821 ATM times liter, divided by mole times Kelvin. So that's our R times RT, which is 273 Kelvin. Okay, notice what units cancel out. We have Kelvin canceled out, ATM cancels out. Okay, so go ahead and plug this into your calculator. And you should get that this equals 0.045. And now we need to look at the units. Well, on the bottom we have liters per mole. So what we really have is 1 over liter over mole, which is equal to mole over liter. So we have 0.045 mole per liter, which is molarity. So that would be our answer. Notice we didn't need this volume. You could have calculated the mole you could have solved for moles using the ideal gas law and then divided the moles by our volume. But since we're solving for molarity, we can just use pressure and temperature to solve for the molarity. Okay, let's try question number 2. Number 2 says, what is the molarity? So again, we're looking for molarity of oxygen gas that exists under a pressure of 784 mmHg and 30 degrees Celsius. So again, we can use our molarity equals P over RT equation. We have, here is our pressure, here is our temperature. But our R is in units. Remember, our R is 0.0821 ATM times liter divided by Kelvin times mole. So we need to first convert our pressure into ATM and our temperature into Kelvin. So we do 784 millimeters of mercury times 1 ATM per 760 millimeters of mercury. So we get 1.03 ATM. And then for our temperature, Kelvin equals 30 degrees Celsius plus 273. So Kelvin is going to be 303. So that will be our temperature. So now we are just going to plug in our values. So molarity equals our 1.03 ATM divided by our R, which is 0.0821 ATM times liters divided by mole times Kelvin times our 303 Kelvin. So now we just plug this in, and again, notice that the same units cancel out, ATM, Kelvin, so we are left with 1 over liters over moles, which is equal to moles divided by liters, because liters and moles is in the denominator, so we're dividing by that, so we can flip it. So it becomes moles per liter. Go ahead and put this in your calculator, and you should get 0.0415 molarity, or moles per liter. Okay, our next question is, how can we incorporate molar mass in the ideal gas law? So how can we use the ideal gas law to solve for molar mass? So again, the ideal gas law is PV equals nRT, and the definition of molar mass is going to be it's going to be grams divided by moles. So notice both of these equations have moles. So what we're going to do is, first we are going to solve our ideal gas law for moles. So for N, we're going to set this equal to N. So that would be PV over RT equals N. And then the second thing we would do is divide given grams by our N, by this. Okay, so let's do some examples. Pause the video and try these examples on your own first. Okay, so for number 1, we are given a mass of 0.311 grams. We are given a volume of 0.225 liters. We are given a temperature of 55 degrees Celsius, and we are given a pressure of 886 millimeters of mercury. Our goal is to find the molar mass. That's what we want to do. And so again, our molar mass is grams per mole. Well, notice we already have grams. So now we need to figure out moles. We have volume, we have temperature, we have pressure, so we can use the ideal gas law. Again, N equals PV over RT. Our pressure is given here, our volume is given here, and our temperature is given here. Whenever using the ideal gas law, because the constant, the ideal gas law constant is in ATM, we need to convert our pressure into ATM. So we are converting our pressure into ATM. And we are converting our temperature into Kelvin. Once we do that, we can just plug in our values. So N is going to equal our pressure, 1.17 ATM, times our volume, 0.225 liters, divided by our R, 0.0821 ATM times liters divided by mole times Kelvin, times our Kelvin, 328K. Okay, to make sure that you did this right, notice what units cancel out. ATM, liters, Kelvin. We're going to be left with moles, which is exactly what we want to be left with. That's what we are trying to figure out. So go ahead and plug this into your calculator. And we get that our moles is 0.00978 moles. So now that we have our moles and we have our grams, we can find out our molar mass. So we are just going to do grams divided by moles, which would be our 0.311 grams divided by our 0.00978 moles, and plug that in your calculator, and you should get 31.8 grams per mole. That would be our molar mass. Okay, the work for number 2 is going to be shown below. So I have converted my pressure into ATM, my volume into liters, and my temperature into Kelvin. Now I am ready to use the ideal gas law to solve for moles. After plugging in my values, I got 0.0117 moles. Now I'm going to use my mass into grams divided by moles to get the molar mass. Notice that the units of mass are in milligrams, so I need to divide that by 1,000, so I really have 0.827 grams. So I'm just going to do 0.827 grams divided by my moles. Plug that into your calculator. And so my molar mass equals 70.7 grams per mole. That would be our solution for number 2. The last one we're going to do is relating the ideal gas law to density. So again, the ideal gas law is PV equals nRT. And the density equation is D equals mass over volume. So again, our overlapping variables in this equation are going to be our volume. And now we need to relate mass to one of our variables in the ideal gas law. We know that mass and moles can be related through molar mass. So if we have moles and we multiply it by molar mass, we would get our grams. We would be able to convert something into mass. So we are going to multiply both sides of our ideal gas law equation by molar mass. So now we have molar mass times pressure times volume equals moles times R times T times molar mass. Moles times molar mass is grams, or is mass. So moles and molar mass will combine to just give us grams. So we have grams times RT equals molar mass times PV. Our density is mass divided by volume, so now we're going to divide both sides by volume. And now we are going to get that molar mass times pressure equals grams divided by volume, which is density, times RT. Let's just get density alone, so we're dividing both sides by RT. And density equals molar mass times pressure divided by RT. Okay, so now let's try some practice. So go ahead and pause the video and try and do this practice on your own. So in question 1, we are looking for density. We are given nitrogen gas, that's N2, so we know its molar mass from the periodic table. We are given temperature in degrees Celsius. We need to convert it into Kelvin. We are given pressure in mmHg, and we need to convert that into ATM. Once we have that, we can use our density equation, and we have every single variable except for density. So go ahead and plug in those variables, and you should get that the density is 0.852 grams per liter. The density of gases we measure in grams per liter. And those will be the only units left between molar mass, pressure, our gas constant, and temperature. Please send me an email or comment on this video if you have any questions and need further explanation.